Welcome. Today we will discuss quadrilaterals. Let us take one example. See this ABCD, it is a quadrilateral. And in this quadrilateral, AB parallel to CD and AD parallel to BC. So, the opposite sides are parallel. It is called as a parallelogram. And AB is equal to CD. That is equal to BC. That is equal to AD. Then this parallelogram is called as rhombus. So the definition of rhombus is a parallelogram in which adjacent sides are equal is called a rhombus. Actually, we will draw the rhombus figure as a kite. I will show that figure too. Why we are drawing the rhombus figure as a kite? Rhombus has a unique property, that is, in the rhombus the diagonals are perpendicularly bisecting. We have to show the angle between the two diagonals as 90 degrees. That is why we want to draw the rhombus like a kite. Just observe. These two diagonals are intersecting at O. Now, 4 triangles have been formed. Each triangle is called right triangle. So, let us write the properties of rhombus. All sides are equal. Actually, the opposite sides are parallel. That is, already we have learnt in parallelogram. That is why you no need to know again, because rhombus is nothing but a parallelogram. So, AB side is equal to BC side is equal to CD is equal to DA, and the diagonals are not equal. But perpendicularly bisecting. In the parallelogram, diagonals are bisecting. Here also bisecting, but the angle between the two diagonals is 90 degrees. So that we have used this word perpendicular. I will show how it is. This is one diagonal. This is another diagonal. Suppose these two also diagonals, but here the angle between the two diagonals is not 90 degrees, but here the angle between the two diagonals is 90 degrees. That is why only we are saying the diagonals are perpendicularly bisecting in the rhombus. So, it is A, B, C, D. In this, OA is equal to OC and OD is equal to OB. If two diagonals are intersecting, then 4 congruent right scalene triangles have been formed. Let us discuss about the triangles formed by the intersection of two diagonals. This is one diagonal, this is another diagonal. We have to join the vertices of the diagonals, that means endpoints. We will name it A, B, C, D. Just observe, this is one triangle, its name is triangle AOD, and we take one more triangle, that is triangle COD. In these two triangles, what are equal? Shall I write OA is equal to OC? How can I write this? Since diagonals are bisecting, this property has come from the property of a parallelogram, and angle AOD is equal to angle COD, that is equal to 90 degrees. This is the property of rhombus. And OD is the common side. By which property these two triangles are congruent? We have chosen one side, another side, and between the two sides one angle. So this is SAS property, not RHS property, because in the RHS property we have to use the hypotenuse. Here the hypotenuse is AD, we are not using this. By SAS property, triangle AOD is congruent to triangle COD. Suppose I am not using this SAS property, then which property can I use? I will show that too. We will take a rhombus, just name them A, B, C, D. Now I will show the two diagonals are perpendicular to each other. We will take two triangles, triangle AOB and triangle COB. I am choosing the two triangles which are downwards to this figure. In these two figures, what are equal? Shall I write AB is equal to BC? What is the reason behind? They are the sides of rhombus. And OB is the common side. And OA is equal to OC. This is the property from parallelogram. By triplets property, triangle AOB congruent to triangle COB. If two triangles are congruent, then we can write that the corresponding parts are equal. What are the corresponding parts in these two triangles? I can write angle OAB is equal to angle OCB. and angle AOB is equal to angle BOC. And angle OBA is equal to OBC. By observing these three, what we get? This angle and this angle are equal. This angle and this angle are equal. From this we can say that the diagonals are bisecting the angle at the vertices. If we take the above two triangles, here also we get the same. These two angles are equal and these two angles are equal. So, from this we can get one property, that is, in the rhombus diagonals bisects the angles at the vertices. And we choose this one, angle AOB is equal to angle BOC. Angle AOB and angle BOC, these two are the linear pair, these two are lying on the same line. So, their sum is 180 degrees. I will write angle AOB plus angle BOC is equal to 180 degrees, since linear pair. Now itself we got that these two are equal and their sum is 180. So what does it mean? It means both the angles have the same measure, that is 90 degrees. So from this we can say that in the rhombus the diagonals are perpendicularly bisecting each other. And the same property, the opposite angles are equal. This has come from the parallelogram, and the same sum of adjacent angles is 180 degrees. We go through one question. Let us take a rhombus. In this rhombus, one diagonal is equal to one of its sides. I will write the question here. In a rhombus, one of its diagonals is equal to its sides. Then find the angles in this rhombus. This is the question. I will draw the rhombus. And the diagonal too. Here I am writing this diagonal AC is equal to its sides. So, I will write this as AC is equal to AB is equal to BC is equal to CD is equal to DA. Now, this triangle ABC is equilateral triangle. In the equilateral triangle, each angle is 60 degrees. That is why I will write 60 degrees, 60 degrees and 60 degrees. And we will take the triangle ADC. This is also equilateral. So, it is also having the same angle 60, 60, 60. So, now observe the angles in the rhombus. They are angle A is equal to 120 degrees, angle B is equal to 60 degrees, angle C is equal to 120 degrees, angle D is equal to 60 degrees. This is also we can remember as a property. If in a rhombus one of its diagonals is equal to its sides, then the angles in the rhombus are 120 degrees, 60 degrees, 120 degrees and 60 degrees. Like this we have to remember.